Welcome to this video about the scientific method, as well as the experimental design process.
This is the general overview of a science and engineering project. In this video, we'll be going over the second step, the scientific method.
The scientific method is a process which scientists follow to answer questions they have. Scientists start by asking themselves a scientific question. They then develop a hypothesis on it or an initial answer. They will change the hypothesis throughout their scientific experiment in response to the result of the experiment. The next few chapters will go into a detailed process of what steps scientists will go through in the scientific method. These steps include making a scientific question, making a good hypothesis, making the variables, recording data, graphing data, analyzing the data, making conclusions about the data. Siddharth will now get us started with these steps.
The scientific question is one of the most important pivotal aspects of your entire project. As we mentioned in our previous video, a proper science and engineering project will never go completely according to plan, and it's important to keep this in mind when drafting your question. You should be prepared to research the entire field of whatever your question deals with, not just the specific variables in your project. So what is a scientific question? A scientific question is an inquiry which determines the objective for your research. It is the product of your curiosity in that subject. Generally, a good scientific question will follow the form as shown on the screen. This means you should be looking at what the output of a certain change is on a certain aspect or value. For example, let's take the example of wanting to research plants and sunlight. You should try to convert this into the format mentioned on the screen. You'd want to see the effects of sunlight on plants, so the question would be, how does the amount of sunlight affect the growth of plants? Notice that the aspects of the question, the amount of sunlight and the growth of plants, is being measured. Creating a question with these kinds of specific attributes is essential to be able to proceed with identifying the variables later on. Pratham will now proceed with the next step, creating a hypothesis.
A good hypothesis follows a certain method that allows room for improvement, but also solidifies a claim in the scientific world. A hypothesis will be your initial answer to your scientific question. You will use experiments to try and prove this hypothesis. If your experiments do not prove this hypothesis, then you will edit your hypothesis and run experiments again until your experiments and hypothesis are in accordance. This hypothesis goes like this. If some event happens, then something happens because of this/these scientific rules. For example, if we had a question like, how does the amount of bacteria affect the purity of water? Our hypothesis would be something like, if the number of bacteria increases, then the purity of water will decrease, because with more unhealthy bacteria producing unhealthy chemicals, the purity of water will decrease. Now that I've gone over what a good hypothesis looks like, let's get some practice on making good hypotheses. So we have this question: how does the amount of sunlight affect plant growth? Try to pause the video and make a good hypothesis for this question. Hopefully you pause the video. Your ideal hypothesis would look something like this. If plants are exposed to sunlight, then plant height will increase because of the plants performing photosynthesis. So these are some good examples of hypothesis. Let's move on to variables.
So variables are the things that you'll be changing, measuring, and controlling throughout an experiment, so you can make sure that the experiment will output the most accurate scientific data that it can possibly do. So there are three types of variables in a scientific experiment. These are the independent variables, which is the variable that you're changing, the dependent variable, which is the variable that you're measuring, and the control variables, which are the variables that are kept the same so you can make sure that you have accurate findings that you can publish in the world. Control variables are important to help you ensure that the only thing that affects the dependent variable of the experiment is the independent variable. This allows you to accurately study only the effects of the independent variable in your experiment. In addition to those three variables, you should have two different groups. So one of them will be an experimental group and the other will be a control group. So the experimental group is the one where you add your independent variable into the baseline with the control variables while you add nothing to the control group. The purpose of categorizing these into groups is to measure how effective your independent variable is compared to no difference at all. So to demonstrate these variables, I'll continue the example that's been said before. So with our experiment, how does sunlight affect plant growth? Our independent variable, the variable that's going to change, would be the level of sunlight. And this is because we would be changing the amount of sunlight to calculate the different effects that it has on plant growth. Therefore, our dependent variable, which is the variable that we're measuring, would be our plant growth, because that's what we want to find out based on the sunlight. Or in other words, it's a measure of plant growth that is dependent on the amount of sunlight. So the next type of variables are the controlled variables. Unlike the last two variables, there could be many control variables in one experiment. For example, the control variables in this sample experiment would be having the same type of soil, having the same amount of water that's being fed to the plants. So in this experiment, if you are exposing one plant to complete darkness only and another to a very bright light like a grow light, your control group would be like the baseline or just regular sunlight. So Jay is now going to talk about how to do background research for your experiment.
Background research is one of the most fundamental steps in this process because this is the time in which you learn what you need to do for your experiment. You'll be asking clarifying questions that will stem from certain words. These words are why, how, who, what, where, and when. You will ask questions and just general questions about the topic and the scientific question. You'll be using many varying sources and you have to record them in APA style for future reference. This document is the document you guys will be using to guide your background research. You can see the preliminary questions that are important to fuel your research. Different question words, the possible question stems, space for your research answers, your APA style resources, and the final question about the formulas that might be used. Pratham will now continue to show you how to record data.
Recording data is the most critical part of the experiment. This is the part where all your prep work and theorizing comes together in reality. By this point, you will already know what you're testing and how you're testing. All that's left is the doing. The important part is to stay alert throughout the entire experimentation process so that you can record each and everything that occurs. Whenever there is a doubt as to whether something is important enough to record, the answer is to always record it. But more specifically, you should record your data in a way that makes most sense to the specific application of your project. You should have a table where you record the change in your dependent variable with different rows for each level of your independent variable. Tables are used to display raw data. Siddharth will now explain how to make sense of that data.
After you have your data, the next step is to make sense of it. Most likely, you're just staring at a table to number. This is where graphing comes in handy. Graphing is probably a technique that you've learned in a previous math class or science class, but you'll be able to see its benefits here in real time. Graphs will help to visualize the raw data from tables, which helps you to understand the data in relation to each other rather than just looking at numbers. As Jay mentioned, data will mostly be recorded by looking at the effect that different levels of the independent variable have on the dependent variable. Based on the context, you should choose which type of graph to use. These may be a bar graph, line graph, or pie chart, or etc. When your independent variable is specific types of categories, you should generally use a bar graph. When your independent variable is time, you should use a line graph. And finally, a pie chart should be used when you're measuring frequency or percentages of occurrences of specific categories. These are just some of the various types of graphs, and there are a lot more that you can use for various other purposes. In a bar graph, your independent variable will represent the different bars, and the level of the bars should be the dependent variables. In a line chart, your independent variable should be recorded on the x-axis, and the dependent variable should be recorded on the y-axis. Finally, the different categories of your independent variables should be the different sections in a pie chart. Jay will explain where to go from here.
After you graph your data and get an idea of what is going on, you will be able to analyze patterns in your data, like the nature of the relationship between your independent and dependent variables. These will most likely follow something along the lines of, as something happens, this reacts by something. Overall, this relationship between the cause and effect should be clear at a conceptual level as well as a mathematical level. Sesha will now continue to tell you how to draw conclusions.
Your conclusion should encompass your entire project from start to finish. You should reiterate all the topics that we covered in this video, from scientific question all the way to data analysis. Most importantly, you should compare your results that you analyze to your original hypothesis and make a decision as to whether your hypothesis was correct or false. One of the main things to keep in mind when drawing conclusions is to make sure that you point out every single thing that you notice in your data and your experiment to try to reason why that might have been the case. Especially when explaining the parallel or lack thereof between your independent variable and dependent variable, you should try to find out the reason as to why that occurred using your data.
So we thank you for watching this video, and in our next video, we'll cover topic selection. As always, if you have any other questions, feel free to email us at the email displayed on the screen, or also you can comment below. Thank you.
This is the Science Squad signing off.